Good morning, everyone.
Hi there.
Hi, Rafa. We are looking for a show queen as well. How are you today?
Not too bad.
Okay. Welcome, everyone.
Hello.
Hello. Hi, Joaquin.
Good
How are
morning.
you?
Good. How are you?
All right. We are good here. Thank God that it's a dry day here in Cork. So we give people around like another minute or so that they would join us. So we have quite a number of people are joining. Right. So I think I'll give another minute or so. What is the picture behind you, Joaquin?
Oh, that's a beach forest in Sweden, I think.
Oh, is it? The forest is that must be in winter, right?
I think it's spring. I think it's very apt for now.
Yeah. So we are welcoming people in our second seminar of the series that we are introducing AI on demand platform for the NoE, but also for the European AI communities as well. So welcome everyone. I would like to welcome every single one of you to spend the time this morning to join us in this 1 hour webinar. And we have our speaker here, Raphael and Joaquin. They will introduce themselves later on. But before I am handing it over to their very capable hand, I would like to introduce a little bit about the AI for Europe and also the AI on demand platform. So what I'm going to do is I'm going to share the screen, and I hope that you can see it.
Hmm?
So my name is Long. You can call me Long, but my whole name is that you can see on the screen as now. And I am with UCC here in Cork, Ireland. We are the coordinating team here, and we are working with our partners and the consortium in building the AI on demand platform, but also the ecosystem and community around it. So the AI for Europe projects, it is a Horizon Europe project funded by the EU, as many of you know, and the project itself is responsible for the management, development, and facilitation of the AI on demand platform that we are actually deep dive a little bit today with our expert. We wanted to it act as an enabling engine behind the platform, but also we wanted to be a renowned channel for AI related knowledge, services, and tool. We also want to have a ecosystem of excellence to accelerate the adoption of solution based on AI, as many of us already know, and also we want to incorporate and improve the use of research in academic, but also in industry and innovation community. So the project itself, we would want to provide the community to provide a community-driven tools to put AI research that scientists, that many of you are, can deploy, customize, and extend. And what we're trying to focus heavily on is actually that it is open access and it is easy accessible, and it's to distribute the share AI resources and knowledge as well. So a bit about the AI on demand platform before I hand over to Rafael is actually they would be in better place to explain to you in details. But here are the ways that we as you see, the aim here is we designed it to empower European research and innovation in AI, while we also want to ensure that European seals of quality, trustworthiness, and explainability. And as I said earlier, it is focusing on the open and openness of the platform, but also the easy accessible to every different community. And there's multiple ways that you can engage with the platform. It could be from the contribute or use the assets or services that we have. Those will be work by our experts today, but you also can learn through the AI educational resources we have on the platform, or you can use the relevant information and resources or data sets on it. Or you can also integrate your services using different part of the platform for dissemination and communication purposes as well. So we have different groups that we targeted here, but mainly would be AI researchers, student, SME, technology provider, digital innovation hub, and other EU-funded project initiative as well. So I don't need to repeat a lot about this, but like what we would want you to be a part of this journey. So that's why you are here with us. We can ask the question using the question function there. And also, we want you to experience a bit with the platform. And after this seminar, I'm going to send you the recording of this seminar, but also with the different links that we are using today, and also the feedback form that you can give us any feedback and any ways that you want to contribute. So that's it. That is my contact details, and if you have further question, I'm happy to get back to you as soon as I can. So that's it from my side. I hand it over to Raphael and Jochen. You can introduce yourself, and then you also can take turns to introduce the platform with its different functions to the community. Thank you.
Thank you so much. Hi, everyone. I'm Joaquin van Schoren. I'm Professor of Machine Learning at the TU Eindhoven, and also leading the work package on the work stream on designing the platform and building the main components of it. Rafael, do you want to introduce yourself?
Thank you. Good morning. So this is Rafael Tolosana. I'm associate professor in the University of Zaragoza and also part of the technical team of the AI on Demand.
Wonderful. I'll share my screen. I'm happy to take questions during the presentation. I'm not sure if I can see the chat, but please interrupt me if there's any question I can answer. Well, 1 second, almost there. Okay. This good? Yeah.
Yes.
Yeah.
Okay. Thank you so much. All right. Let's dive into the platform. This will be more of an overview of what we're building, what's already there, and a little bit into the technical part, so you have some idea how to use it, but not too deeply. If there's anything you want to dive more deeply upon, just ask questions, and we're happy to go more into the weeds. Right. So open on the AI on Demand platform. The idea there is to bring together all of your existing AI data, software platforms, and so on. So Europe is very advanced in building AI things and doing AI research. The problem is it's very distributed. It's often hard to find what's being done, and that's a pity, right? Because we do so much very nice things, but it's very sometimes hard to find those. Right? And so the idea behind this platform was to bring this all together. And primarily to support the needs of AI researchers, right? So researchers should be able to compete with the world. So they should be able to find the latest AI resources. They should have ways to run experiments. They should have ways to announce and distribute their work. And so the platform is meant to do all of that. How do you want to do that? Well, first of all, we're going to try to integrate as much as possible all the AI resources. I mean, data sets, models, but also experiments and compute resources and software code, and make it easy to find. Build interfaces that make it easy to find those, like search engines and chatbots. So you can just go on a platform and ask for, I'm looking for resources about that, and a chatbot may be able to help you with that. And secondly, to integrate but not duplicate existing AI services. So there are already many interesting platforms in Europe, outside of Europe. It's a big world. And so we don't want to duplicate all of that. We can't duplicate all of that. And we also don't want to hurt the communities that are around all those platforms. So what we want to do is to integrate all of them in the same platform. So you can go on the platform, you can find resources, whether they are on OpenML, on Hugging Face, on the platform itself, and so on. So you can find those resources and access them in a uniform way. And also make it easy for people to build new things on top of this. So it shouldn't matter where those resources are. You should be able to build new software, like if you're like a machine learning researcher, you should be able to write new machine learning algorithms and test them on different data sets, no matter where they are. If you are building AI services, maybe you have an advanced service to find the best AI models. You can also do that. You can build layers on top of the platform to build those systems. So what we'll talk about specifically now is the things we built so far. So these are the AI on-demand resource catalog. It's a big catalog of all data sets and models and so on that you can find on the platform. I'll also explain you how you can add your own resources to it. I will talk about a little bit the search engines and the chatbots that we're building. The search engines are already there in the first version. The chatbots we're still developing. And we have an API, very important to exchange resources. So you don't have to do things manually through a website. You can actually talk to the service via code, via the internet, right? So you can share your resources. You can pull in resources into your code. Like say you have a Jupyter notebook, you can just ask, give me that data set, it will pull it into your notebook. Also, if you have resources, you can share them easily programmatically. So if you have 1,000 data sets, you can upload them all at once using a few lines of code and so on. Right? And then we have services that perform more advanced tasks. Right? So you want to do benchmarking of experiments, or then there are specialized services that help you do that. Okay. So there's a whole idea. So in the center, on the image on the right here, we organize all those AI resources. We build a big catalog of it. And then we have this API interface that allows programmatic interface. And on top of that, we build websites, we build chatbots, we build program interfaces, services, and so on. So you can also access those resources. Right? And those resources, they may live on our own platform, but they may also live on other platforms. Like they may live on Hugging Face or in an HPC center where they have large storage facilities and so on. So that's the idea of the platform. Yeah, cool. It's a distributed architecture, right? So it's not one big server somewhere. It's kind of you can view it as a cloud resource, right? So which consists not of one server but a number of what we call root nodes. So root nodes are just centers, hardware basically, where, or it could be cloud, where the core AI services run. Like this is where you can access the resource catalog, where we have metadata about all the data sets and so on. And those will be hosted in different sites in Europe, depending where the available resources are. And these root nodes also, so they keep their own resources, but they also have connectors to other centers where they have resources. Like maybe there's a very large data set that lives somewhere on an HPC center, it can access that. Or maybe there's a platform somewhere in Europe that already has resources, it can connect to that as well, right? So those root nodes kind of hold everything together, make it distributed. So if one root node goes down, the system is still fully operational. They will also exchange metadata so they know There's always a copy of all the information. Yeah. And then external resources are things that can offer data. They can be like data resources, data storages, or they can be compute facilities like Euro HPC, the high performance computing centers, which may actually give you compute to build models and so on. And then you have the leaf nodes. So the leaf nodes are basically oftentimes existing resources. Maybe your research center already has a service, a platform that they want to connect to the platform, so that you can do that as well. So you can integrate your existing resources into the platform as a leaf node, which means you don't have to host everything. You just host your own tiny part that you want to offer. Like could be a data set, it could be a cool tool that you have, and you can integrate with the platform. So people will be able to go on the platform and find, oh, there's a service here offered by this university. You will be able to find it and use it. Right, that's the whole high level view. Let's dive a little bit deeper into the architecture. This is the software architecture. Don't worry too much about the complexity. I'll explain this step by step. So it's designed for basically three types of users. One are researchers, right? So they want to access all the AI resources. They want to create their own AI resources. They want to create their own models, for instance. Say you want to build a large language model. You can get access to data sets and so on. Build those models, share those models so other people can use them. So, and the whole idea is to speed up research and innovation in AI in Europe. Then you have educators, teachers, professors, and so on, who are teaching the next generation of resource of AI professionals and researchers. So they'll be able to use it as a research, as a teaching platform. They can find services, they can give students access to resources, and they can also like build their own teaching tools on top of it. And then also, very importantly, students who are learning about AI, they can also interact with those resources. They will find a host of, hopefully soon, a host of very different services that they can use to learn about AI. Right, so how do those people access it? One way is to access it directly via the API. So if you're good at coding, you can just import AOID, get data sets, right? You can do that as well. Besides that, we have more intuitive interfaces like websites, like search engines, chatbots, and so on. So you can go online, do a search, and find resources that you want. And next to it, we have services. So services are more advanced things like to do large-scale benchmarking, or to maybe you want to build a tool that evaluates whether a large language model is safe for use, or you want to benchmark in other ways. So you can build your own services also on top of that. So these are all interfaces that people can find. So anybody could be able to access it. We won't build all of it, but we can't. But we offer the platform so people can build new services, what they find cool, what they find useful. So let's use the ingenuity of the whole of Europe to build interesting services, and people can access it to this. They won't often even know that AID is underneath it. It will be easier for people to build those new services. And then below that is a layer where what we call the API. So it's the application programming interface. So this is where you actually have code access to all the resources. So there's the big catalog, a big database basically of all the resources, APIs to talk to it. So you can talk to it in Python, for instance. And all the nitty-gritty stuff like authentication, access control, resource allocation, so everything is safe for use. Right. So that will have all the metadata basically about all the data sets and so on, and the compute. And the actual data storage and compute that lives on other AI resources, your existing HPC centers, your existing data storages, existing platforms that we connect to. Right. No questions for now? Okay. So I'll briefly go over the current interfaces. So on one hand, we have a web portal where you can find general information. We have a search engine, which is called My Library right now. It's an early version, but you can already use it. You can search what kind of resources are available. We have APIs, so you can access it programmatically via code, like via Python, for instance. and we have several services. They may look very differently depending on what they are. They typically have their own website where you can do more advanced things, and they have more advanced interfaces to do more advanced things, of course. First thing, my library. So this is kind of the search engine for now. So you can go there. It does link, by the way. So it's mylibrary.aod.eu. So you can go there, and there's a very simple search interface for that. This is kind of the first beta release of it, right? So it's very simple right now. We're making this much more intuitive and functional right now. So here you can search for anything you want. You can search for models, data sets, experiments, and services. We're hoping to extend that later also to papers, publications, other resources, courses, and so on. But for now, this is what we offer. But our API is our resource catalog is much wider. So we have our list of courses, we have lists of events, we have lists of so on, but that will also be integrated in the near future. So you can search there, you can do a little search, you can find all this case, these are data sets, right? And there are like tens of thousands of data sets or hundreds of, I think it's between tens of thousands, hundreds of thousands of data sets right now, I believe. And so you can find those. And if you like some of them, you can also like tag them and build your own little library of the data sets and the models and so on that you like, so you can find them easily. Right. Then you have the portal. The portal is the general website for the platform where you can find all information. So events, services, and so on. So there you'll have a list of services as well. But you can also learn about events, training opportunities, and so on. Also work in progress. So this will also be continuously updated over the next years. And then we have the Python interface, or the SDK, the software developer toolkit. This is basically the programmatic access to Python. So if you know how to use Python, you can access open the AOID. So you can just import it. It's basically pip install AOID, and then you import it, and then you can use code, like get a list of all the, in this case, all the data sets, right? So you get a list of all the data sets. And so you can see, okay, this is like a data set on reviews on Allegro, and this actually lives on Hugging Face. You can see when it was published and so on. So you get this big data frame of all the data sets, and you can peruse all of that. You can programmatically search through them, anything you want. You can also add like search parameters to it if you only want to have certain data sets and so on. Of course, you can do that too. That's the idea. You can just use your code or your Jupyter notebooks to access all the data sets, for instance, or to import models. So you can very easily write some code that imports a data set, imports a model, trains the model, and maybe even share results back on the platform. So that's all possible. Right. Yeah, so this connects to the IDE. So you can very easily install it with pip install. You can do search, like this is searching for all the platforms that are integrated, like OpenML, Hugging Face, and Dodo, and so on. If you are really into the details, you can also write your own interface. So this is the Python interface that we offer. That's being developed, but we also have a REST API. So if you want to build your own API in R or Scala or Julia, you can do that too. You have to do a little bit more work, but you can do that because everything is based on REST. Yeah, you can do more advanced things like actually what you do here, but yeah, you can go really deep into all the details of all the data sets and all the resources we have. Our metadata is quite extensive, so we keep a lot of data on all the data, all the models, so you can really search for the ones you need. One of the services I can bring up is Rail. So Rail is an experimentation service. It's a reproducible AI experimentation service. So what you can do there, you can pull in a data set. You can set up you can train a model on a data set, for instance, right? And then this will run on some hardware, and you can track the progress. Sorry, you can track the progress of the training. So here we're training a PyTorch model, and then you can enable the result. So this makes it very easy to run experiments, which are also reproducible. So other people can also repeat your experiments. We also have a more intuitive interface. This is called the AI Builder. So this is purely graphical. So you can basically like have a canvas where you can like drag a data set, drag a model, train it, and so on. Yeah, so that's you can access that on aibuilder.aoi.eu, and you can also experiment with that if you like to build models this way. And then we have integrations. Like I said, we can't do all of AI on one platform, so we integrate with existing platforms. So, for instance, our catalog service, we don't host all the data sets. We can actually host data sets as well, but oftentimes data set already lives somewhere. So the data sets actually could be on a root node or some leaf node or an existing platform like OpenML or Hugging Face or Zenodo. And for these, we build connectors. These connectors will frequently access, for instance, OpenML, ask like which are all the data sets you have, are there any new data sets that you have? And if so, we will also index them so people can easily find them. Same for Hugging Face, same for Zenodo. So you can find papers, you can find models and so on, and they're all connected. There's a whole lot of detail behind it, of course, but we make sure that you get a very nice overview of all the available resources, no matter where they actually live. And this is nice because you have one interface for everything. You can build services on top of that. You're less bound to changes in the other platforms, but you can still use. So you get the benefit of everything. You get the benefit of the individual platforms, and you get the benefit of having everything combined. And then we have finally a list of other services. So these can live on root nodes or leaf nodes, right? So I already mentioned some of them. Other services are like the reproducibility checklists, so checks whether experiments are reproducible, list of success stories. Robopump, this is another service for robotic research. All of things like navigators, actually don't know all of them in detail. So people have been building other services on top of them as well. So you can find them as well. I think that's it for me. Any questions right now?
Yes, Joaquin, there's one question in the question part. There's two now. So if you can help to address those before we come to Raphael, please.
Sure. Okay. So one question is, how do you access data sets from the AI on-demand dataset list? Right. So I assume you're talking about, like, say you use the API and you get a data set. So typically, it depends a bit on the data sets and where they live. For some of them, you'll get a URL where actually like a data frame lives. For others, like OpenML is actually more integrated, so you can actually like download the data directly into a data frame. So it depends a bit where the data sets live. So we do our best to make it as easy as possible. And so for some platforms, it's very easy. For other platforms, it's a bit harder. Like if there's a data loader, it makes it easier to load the data sets. If not, you may need to go to a website, but then the website explains to you how to get the data. Right? This is to make it more flexible because sometimes you can't always get direct access to a data set. Sometimes you need like additional, like if it's a medical data set, you need additional credentials. If it's data set living on a platform, you may need another login to the other platform to actually access it. But we bring the data together and make it as easy as possible to directly load the data as well. I hope that's correct. Good. Then we have a question for Thomas. So he wants to know about integration with European HPC supercomputers, like the Lumi supercomputer. That's a good question. So this is a very complicated question as well, because the supercomputers, they have their own interfaces. So that like the joint undertaking, the GU. And so they, okay, so right now, today, you would still need to actually have a way to you would need an account on the supercomputers to access resources they have there, like the computer data. There are other European projects that are now either running or in review that will facilitate further access and to further break it down. So right now we have AOID and we have the the HPC resources, and we have some view of what the HPC centers offer. It's not like a seamless connection right now, but there are new EU projects that are meant to bridge that gap. So you might in the future, hopefully, be able to say for instance, to link your AOID account or whatever account you have, or maybe you register an AOID with your HPC account, and we'll try to make it as seamless as possible so you can access those resources as well. I hope it answers your question, Thomas. So for now, you would be able to find. So say, let's take a use case. Say you want to build a large model on a Lumi supercomputer. You could use AI on demand to see which data sets are there. Some of them may already live on Lumi, some of them you may need to copy over. And then you would actually need to go to Lumi to actually run the resources. In the future, we hope that there will be a service that we can offer where you can just say, oh, I want to take this data set, I want to build this model, I want to build it on that supercomputer, and it just will work. Right? But right now it's not possible, but that's the idea. So it's technically possible, but it's also political. Like the HPC centers need to provide access in it, so we need to figure out how to unify that access to all of Europe, and that's something that will happen in the next project. Okay. Another question anonymously. I am a model provider. How can I upload my models on the platform? Very good question. So how do you upload your own models? There are two ways. So you can either just go on AOID. Let's see. So we don't have any. I don't think we have a drag and drop interface right now, but we can add that. That's one thing. So you can store things directly on our root nodes. You can also share them via the API. I'm actually not sure whether that's already. I think it is supported already. Yes, I think if you go to I'm not sure if it's supported by the Python API yet, but very soon you'll be able to say, "This is my model. I want to share it," and you would be able to do it via the Python interface, like build your model object and share it with the platform. Another thing you can do, so like we don't force you to put everything on one platform. So if you think that your model, if you should live on Hugging Face or whatever, right? You can also put it there, and we can pick it up from there. And it will also be indexed in AOID, so people will be able to find your model if it lives in Hugging Face as well. So you're free to use the resources you have. I can imagine other services being offered in the future. AI is developing very rapidly. Yeah, so that's the thing. So you can either store it on our own platform or on an existing platform that's connected to the AOID. Okay.
I think that would be it for Joaquin. Now we would hand over to Raphael, please. Thank you, Joaquin, and please stay on until the end, so we may have a few more questions from the audience. Thank you.
You're welcome.
Okay, good morning. Thank you. Thank you, Joaquin. Thank you very much. So let me share my screen. Okay, so I wanted to bring some comments on the engagement with the community and highlight its importance. And I want to start my words with something that actually happened to us when designing my library. So there are many. This project is quite big. There are many colleagues doing many wonderful stuffs. One of them are social scientists, and they were conducting research on what are the difficulties of PhD students in AI in Europe. So they conducted a survey, they asked them questions, and they collected them, and then they analyzed them. So there are 3 or 4 findings out of them. They just selected 2 of them because they're of interest for highlighting what happened to us with the technical part. So the first thing that they found is that PhD students, they have difficulties to find AI resources understood by AI resources, datasets, models, experiments, and code. So our metadata catalog that Joaquin explained so well, it can be used to alleviate that problem, right? Because we aggregate different heterogeneous sources, the node OpenML, Hugging Face. So it's and also many European projects are gonna upload their materials there. So maybe PhD students can find the resources there, and it's something easier because we offer a unified interface to do that. The second big challenge that they found is once they find a paper, they cannot reproduce the experiments in there. Okay, so the first the first conclusion out of that is that maybe sharing is not enough. So look, that this is a bit contradictory to the finding or the discoverability of AI resources that I was mentioning before. And if you think of it, there is Hugging Face, there is Kaggle, there is papers with code, and there is GitHub. So researchers are actually sharing their stuff already. But it seems like this is not enough to reproduce the papers, the experiments in the papers. So there is also one aspect of our project, which is reproducibility of experiments, and we have a reproducibility initiative. So we're studying reproducibility of AI research from a practical point of view, analyzing current practice in different conferences and so on. So we have what we call the AI on Demand Reproducibility Initiative, and I put a link there to a talk that we gave some weeks ago, where you can see in detail the barriers to reproducibility, starting from technical, social, what is current practice, and how can we overcome these things, how we are working on this project to take care of all these challenges. And I just want to take some part of it. What is current practice out of that? So let me see if I can. I'm not really familiar with Zoom. Let me see if I can share only the. So you can see now the whole slides. Okay, let me see if I can share, because I want to share you. Okay, so let's look at so there are different conferences right now out there that they're curating and evaluating reproducibility of the published papers. So that's what all reproducibility initiatives are about. So in AI, you have, for instance, MLC's conference, where they give authors a number of steps that they need to follow so that they can share their computational artifacts, they can share their datasets, models, experiments, and with some additional documentation and ways of packaging everything so that they create like an out-of-the-box artifact so they can be easily rerun by third-party researchers or the evaluators. So if we look at, can you see the screen now? The IEEE.
Yes, we
So
can. Thank you.
wonderful, thank you. So if you look at the IEEE digital library, so this is one paper here that you can find, and you can see there is a badge. This is a reproducibility badge. It means that once the paper was accepted for publication, there is a committee that evaluated the reproducibility of this paper, and because it was successful, they managed to reproduce the experiments. They granted a badge, a reproducibility badge. So if we click here, we go down, and we can see the code here, and we can rerun it. It's an out-of-the-box solution, right? So if we go to ACM, you can see, once you see the result again, you see different reproducibility batches here. This is the evaluated functional, means that you can play with it, and there is some good potential to reproduce the experiments. That's what it means. Artifacts available batch means that the artifacts have, so the dataset, code, experiment, everything required is available. And then results reproduced means that they managed to get exact reproduced of the experiments that are appearing in the paper with the code. So the question is, where is the artifacts? Where are the data sets? Where are the models? So far you see the batches, you see the paper, all these things. So if we open the PDF of the paper, if I manage to do that, And then you go to the end, or somewhere here, you can see the artifact in a GitHub here. You can see that the link, and then you need to navigate through the GitHub and start to find things. And maybe there is GitHub is only for code, and then you have the data set somewhere else. So you need to dive in the paper and try to retrieve all this information. Okay. So if we go to machine learning sys, so they don't have they don't follow ACM and IEEE, which is wonderful. They're saying, okay, we follow our own proceedings server. So if we go here, this is the list of the papers accepted for machine learning sys 2020. The second one has reproducibility. This one here in the list has a reproducibility batches assigned. So if you click here in the paper, then you can see the 3 batches again from ACM, artifacts available, artifacts evaluated, functional, and results replicated. Then you need to go to the end of the paper to try to find the documentation of the artifact. So machine learning sys is having a great reproducible initiative. I really love it. It's fantastic. So here is the instructions, artifact reproducibility instructions. So you need to go here, click again to the GitHub, and then navigate through here. So there is more information here about the installation steps. So it's a bit, to me, all this is a tragedy, right? Because it takes a huge effort to do the reproducibility evaluation. As you can see, the ACM digital library, IEEE digital library, they are working on allocating all these batches and everything, and everybody's working hard to do that. But then how can I find these curated elements? So this is, if we go back to what PhD students were complaining, once they find a paper, they cannot reproduce the experiments. But then they also have difficulties to find the resources. So we have a lot of conferences going on right now where you can really have these resources curated, evaluated, that they represent like an out-of-the-box component to be rerun, but then it's lost. It's not indexed by some. So by looking at this, so we were working on the redesign of my library. So our my library right now is this one. This is the version of my library. So we were working on the second version of this, and then we saw this result from our colleagues in the project working on social aspects. And we were thinking, my goodness, can we do something better? Can we really take into account all this? So the new redesign of my library, which is here, so we were looking to have a more attractive graphical design. Okay, so we are also looking at OpenML, for instance, that they have a great experience on these interfaces and building the community. So we are also looking at ways of displaying the information like they are doing, like this view, like you have here. And we are also looking at that way of being able to navigate across the relationships between papers, data sets, and models, experiments. So for instance, I can select a conference like machine learning sys within our metadata catalog in my library, and then I can select, give me all the papers in my MLSys that have a reproducibility patch. And then I can navigate through the data sets. What are the data sets being used that are curated, right, from the conference? Give me all the so I'm looking for a model, or models, specific models within MLC, so I can navigate. So we are exploring all these things, all these navigations, right? This is something we believe it could be useful. But what I want to say is that all this happened and appeared, the opportunities, because of that engagement with the community. So sometimes we sit down and we discuss, we have endless discussions about how we can depict requirements, what is required by the community, but this is done just by our understanding. That's not enough. So maybe from my saying, I can inspire you and say, okay, why don't you do this? So if you think you can contribute to give us some ideas, and that actually this is for all of us, right? This is for the community. So it's a public service. So if you really want to say something, please contact us, and maybe we can move into a different direction. We are still in time to do that. So the second thing I wanted to say is related to, if I'm not mistaken, is so the platform is designed for the community, so the community can it's designing openness criteria. So it's designed so that anybody in the community can extend that, right? So this is the general architecture. Here you have the metadata catalog, you have the identity management service, and then you have all these components here to run experiments. So Rael, for instance, which is this service here that Joaquin already mentioned, it's providing a way to try experiments, AI experiments, right? So it's what I want to say. It's also connected to one of the questions that you previously asked, which is about how I am a practitioner. I want to upload an AI model. So I want to go further. I'm a researcher in AI, and I want to provide one of these out-of-the-box solutions. I have my AI experiment for instance, I want to upload that to machine learning sys and apply for the reproducibility badges, and I want my assets to be assessed. How can we do something in AI for Europe and in the AI on demand to help them, right? So we're working on these interfaces right now at this right moment. So there is a component from some colleagues from Valencia called Aitana. So Aitana is offering 3 different interfaces to upload AI experiments. So one of the interfaces is a graphical interface, a web interface, so like the one that Joaquin mentioned, that we can drag and drop. Okay, so that's one thing. The second thing, the second interface that they offer is a command line interface, similar to our SDK. So we probably will integrate that in our SDK. And the third one is in Visual Studio Code plugin. So you because that's a very common interface to environment to program for us. So we have the Aitana has a plugin already integrated with that, and then they are integrating that with the metadata catalog, so people can configure the experiments. And the idea is that that thing will upload immediately into the metadata catalog and so on. So the design of Rael is also the one part of the Rael design is also inspired by that, right? So what we want is maybe we will integrate Rael, Aitana, or we will. This is something we are looking at. How can we integrate different tools and different parts of them? So this is one of the aspects that we are looking at, right? So for instance, you can see here Rael, so you can create a template of experiments, which is essentially a container. So you can, and currently we have Python containers, so you can run them your code there. But there might be others appearing in the future. So once you have the template, you can set up your experiment here. You can also look for data sets here. I think there was a previous seminar for this community as well that was given by Martin, our colleague Martin, and he was giving an overview of Rail. So I'm not going to enter into the details of Rail, but that's a bit the idea. Okay, so Rail is leveraging Rihanna. So Rihanna is a component here in our architecture that is offering a homogeneous access to different computational resources. So it could be HPC, it could be Condor, it could be Kubernetes, it could be a single machine. That's the idea. So Rihanna is, we are exploiting Rihanna like a plugin to different heterogeneous environments. So Rael is also serving for me in this talk to explain how can we build a service with the three main pillars of the AI on demand, right? So the three main pillars are the metadata catalog, the identity management service, and the experimentation API, which is essentially Rihanna based. So as you can see here in Braille, so they build their front end on top of that. That's what I showed you, which, by the way, I want to say that we are now working with graphical designers to make it beautiful and more usable. And Rail will also offer the SDK, so we will extend current SDK to make it programmatically usable from Python. And then there is a Rail backend, which is connected to the metadata catalog and is connected to Rihanna, so we can leverage these services to make another one, right? But what are the ways we offer in the AI on demand to connect to the community and allow them to all of you to leverage the AI on demand and exploit that. So first of all, you can share your computational assets, right? Your AI resources. I mean, you can share your data sets, your code, and your experiments in the ways that I mentioned, and they all will be stored here in the metadata catalog. So I think that in the audience is Miguel, the Prado. So with them, they were the first. They from One SAP's project and Stairway. We depicted this process so that if I am in one of these projects or I am an AI researcher and I want to upload materials into the AI on demand metadata catalog, what should I do? What are the specs, the steps? So the steps first, you need to build a conceptual mapping between what you want to store and what the metadata schema in the AI on demand is. So our metadata schema is generic enough to support this storage. So then you need to build that transformation, which is technically called crosswalk. So you transform your knowledge representation into the metadata schema representation. Then you need to build a harvester. So you need to extract your information from your premises or from your AI resources. And then eventually you need to insert that into the metadata catalog. And this process can be synchronous. So it means that any change that happens in your information immediately populates automatically into the AI on demand, or it could be asynchronous, which means that whenever you decide that the information should be transferred, it will be transferred. So this is one aspect. We want the community to be able to share their AI resources. The second thing that we could do is we can share services. So for instance, we could build a Rail service, right? So we leverage the metadata catalog, the experimentation services, and the identity management service, which is, well, we didn't say anything about that. So it's based on Keycloak, and it supports one single sign-on, and then you don't have to log in again, right? So this is the idea, for instance, in that you do in Google when you use Google products. So you sign on once, and then you can use Gmail, you can use Drive, and everything, right? So and finally, what I would like to say is that we are also working on sharing computational resources. So imagine that I am an institution that has a supercomputer and I want to let my supercomputer part of it under a control scenario to be shared for the AI on demand, or I have a small data center, or I have a data center, some of the machines I want to share them. For instance, we want to organize a conference, and we are collecting some machines, and then so this is the scenario we're working on right now. So there will be some rules for sharing, deciding upon who is able to share and which conditions and so on, who is going to be able to use them and so on, right? So this is the idea. And that's all on my part. Thank you very much.
Thank you, Raphael. There's a question, open question in the Q&A, if you can help to answer that. And there's also another question that I accidentally put it as answered, but it hasn't been answered. Can you have the open question, and then
Yeah.
I'll read the other one. Thank you.
Okay, great, thank you. So this is Aitor, Research and Development Engineer, and wondering to know if it is there available any onboarding documentation to use the platform. Well, there's some videos in YouTube that we need to update. They're a bit obsolete right now. And there is in GitHub, you can see some documentation on that. I know that there are some colleagues working on large language models to create a chatbot, right, Joaquin? So you can, I think to me, that would be really great, right? We can have all this documentation embedded in one of these chatbots, so you can really find it easier, right?
Yeah, so when we released the REST API, we had a series of videos, like 7 videos, where we explained how to use REST API. I'm guessing you really want to use the Python API. So that's not really released yet. I think they will be this summer, and then we'll also have extensive documentation around that as well.
So in the API, you also have the documentation of all the schemas and everything for
Sure,
instance.
yeah, that's
So if we go to redoc, so you have all the fields appearing here and what are they about. So you can see the description. So it's, I mean, it needs more work, but
and
we're on that.
this is very good documentation for people who want to build their own APIs.
Mhm.
So it's exactly what you have. So you can, but I think for most people, they probably want to use a Python API, and that documentation is still being done. So I think that will come early this summer.
So the other questions. So
Raphael, I send it to you in direct message.
okay, so do you see scalability problems to review and verify reproducibility of all published papers? Yes, of course. So I have a bit of experience in that, and that's a big problem. So reproducibility is complex, right? So we have technical barriers, which is perhaps easier to overcome. Then we have social barriers. So one of the social barriers is how to convince people to change their way of doing things, which is required for reproducibility purposes. But also, it's difficult to find reviewers, and it's even more difficult to find reviewers with training in that. So you can find reviews, but then we are all learning on the way. So, but that's not really. I mean, it's connected to the project, but it's something that conferences and journals need to handle, right?
I think the answer here in longer term is, I think, reproducibility by design, right? So having the platforms like Rafael described, if we have good reproducibility systems, people can run experiments and then have a link that's on AOID or somewhere else, whatever source they have, and just put a link in the paper. Like if you go to this link, you will see all the details of my experiments, and you will find ways to reproduce them. I think we need systems around that that are easy enough to use. I think there are some systems already. They're not easy enough to use yet, and people still do their own custom work. But I think the real answer here to reproducibility is to have good integration, have good systems, so you can just have all your experiments like on a tensor board, and but then be able to share it with the reviewers and anybody else who wants to look at all the details. It is the real scalability answer.
Yeah, I think we are on the dot mostly. So we would like to thank you to Rafael and Joaquin for spending the time to walk us through the different part of the platform today. And as I said earlier, we thankful for your participation and the audience. And I will send out a follow-up email with all the links that we use today and a feedback form link and also the recording of this seminar so that you can have a look at it and you can give us some feedback. your contribution will be crucial for us to be on the right track. And we have multiple ways that we will try to continue to work with you and have you engaging in our community soon enough. So do stay in touch with us, and have a great day. We do know that you have a lot to do today, but we appreciate your participation this morning. I hope it's okay with you.
Thank you.
Thank you so
Bye-bye.
much. If you have questions,
Everyone,
all right.
no more question. Bye bye. Thanks. I'm going to close the seminar now. Bye bye.